Hello and welcome to Maths with Cats. This is my second video in AQA A-Level Maths. Today we're going to be covering laws of indices and surds. Now this is going to be a quicker one because you should know most of this from GCSE, so it should just be a quick refresher. You'll also notice that I'll go over a load of rules at the beginning, but we don't do many questions involving them. That's because I couldn't find many questions that did involve them. So what I will be that didn't require knowledge that I've not gone over yet. So what I will be doing is I don't know how often, but I'll go over an exam paper so that people who are further on in the course can have some opportunity to do some questions, and even if you're not at that point in the course, you can watch it, and stuff you understand great, stuff you don't understand, that's okay too. Cat! So yeah, we will be continuing the cat thing because I like that. So the main laws of indices, these are important to know, and the first one is a to the m times by a to the n is equal to a to the m plus n. So I know I say my m's and my n's very similarly, so I'm trying my best to enunciate them. So this rule, a to the m times by a to the n equals a to the m plus n. What does that mean? If you multiply two numbers, you add the powers. So a to the m plus n. Now, some people, because people learn different ways, need to sub numbers into this for them to be able to memorize it, because if it makes more sense to them if you do that. So if you want to sub into numbers, so 2 to the power of 1 times by 2 to the power of 2 is equal to 2 to the power of 3. Well, if you think about it, we're doing 2 times by 4, which is 8, and 2 to the power of 3 is 8, so it works. Next one, a to the m over a to the n is equal to a to the m minus n. What does this mean? If you divide two numbers, you subtract the powers. So let's do a to the 2 over a to the 1. Well, based off this rule, that should equal a to the 1. Subbing. Oh, I meant to say 2 to the 2. 2 to the 1 should equal 2 to the 1. So 2 squared is 4, 2 to the 1 is 2. 4 over 2 is 2, which is 2 to the 1. So it works. A to the power of m all to the power of n is equal to a to the power of mn. So if you put a power to a power, multiply the powers. That's how I always remember it. So I worded it probably slightly different to how a teacher would, but that's how I've always remembered it. So a to the power of m to the power of n is equal a to the power of mn. Sub in some numbers. 2 squared to the power of 2. Well, 2 squared is 4 to the power 4, and then that squared is 16, and 2 times 2 is 4, so 2 to the 4, well, 2 times 2 is 4, times 2 is 8, times 2 is 16, so it works. I feel like I explained that one slightly badly, but it works. Okay, so I've put these two rules together because they're actually very similar rules. So a to the power of 1 over m is equal to the nth root of a. So the denominator of a fractional power is the nth root. And sorry if you heard that, my cat is snoring in the background. A to the power of m over n is the same as the nth root of a to the power of m. So again, the denominator is the nth root and the numerator is the power. Now, it's written in two ways here. Either way works and gives the same result. Depending on which numbers you have, you might want to do it in a different order, so you might want to write it differently. Works either way. So if you put a number to a fractional power, you can write the number as a root. I'm not going to go over this as with number examples. You can try it on your calculator. It becomes a lot more confusing just saying them out loud. And if I was to write them here whilst talking to you, it would also be a problem because I'm writing with a mouse and it'd take a long time. So if you want to try it, try it. A to the minus m is the same as 1 over a to the m. So a negative power means the number can be written as a fraction with the number to the positive power as the denominator. A to the 0 equals 1. Any number to the power of 0 is 1. That's all it is. I struggled to understand that at first, but it makes sense now. You can get your head around it eventually. Cat! So here's some examples of some mainly surd questions, I think these are. So simplify root 18. Well, what you want to do is you want to try and write the number under the root as the product of a square number and another number. So 9 times 2 is 18, and 9 is a square number. So the square root of 9 times 2 is the same as the square root of 18. 1 second, I just need to take a drink. Okay, and then that can be written as the square root of 9 times by the square root of 2. And the square root of 9 is 3, so that's 3 times root 2, which is 3 root 2. So, simplifying it, you want to get the number under the square root to be as small as possible, most likely a third. Yeah! Okay, simplify the square root of 5 over 64. Well, that's the same as the square root of 5 over the square root of 64. And the square root of 64 is 8, so we're going to write it as root 5 over 8. And that's it. You've done it. Cat! Okay, it's being a bit slow now. There we go. So this one, you're expanding brackets just like you would for a quadratic. So you can write it out twice if you find that easier. And then I personally, with surds, prefer to use a table just to set it out more clearly. So 2 root 3 times by 2 root 3, that's 4 times by root 3 times root 3, which is 4 times 3, which is 12. 2 root 3 times 3 root 5, and it's the same in both these boxes, so I'm all going to go over it once. 2 times 3 gives 6, and we have root of 3 times 5 from these two. So that's 6 root 15. So again, same both. And then here, 3 root 5 times 3 root 5, that's 9 times root 5 times root 5, which is 9 times 5, which is 45. So let's write that out. So that's we can add the 12 and 45 together and the 2 6 root 15s to get this. And that is the answer. Cat! Okay, rationalising the denominator. This is when you remove the surd from the denominator of a fraction, but it still has to be equal to the same thing. Cat! So here's an example. Rationalise 4 divided by root 2. So we're going to times by root 2 on the top and bottom to cancel out the roots. Now, you're allowed to do this because root 2 over root 2 is equal to 1. So the fraction will still have the same value because you're essentially timesing it by 1. So that gives us 4 root 2 over the square root of 2 times 2, which is 4 root 2 over the square root of 4, which is 4 root 2 over 2, which is 2 root 2. So we've rationalised it because there's no longer a third on the denominator. Cat! Okay, next one. Rationalise 1 over 1 plus root 3. Now this one, a bit more complicated because to cancel out the thirds, you have to times by 1 minus root 3. So you switch the sign between the number and the third. This is allowed because 1 minus root 3 over 1 minus root 3 is equal to 1. So once again, we're essentially timesing by 1, but we're timesing by 1 in a way that will give us what we want. So table for the bottom bit because we're timesing two things with both numbers and surds. So 1 times 1 is 1. 1 times root 3 is root 3. Minus root 3 times 1 is minus root 3. Minus root 3 times positive root 3 is minus 3. So we end up with something like this. 1 minus root 3 divided by 1 plus root 3 minus root 3 minus 3. So you can see the surds cancel out there. You end up with 1 minus root 3 over minus 2. You can write this as minus a half plus root 3 over 2. Either of these answers, unless it asks for it in a specific form, would be accepted in an exam. So you just write it how you prefer, like I say, unless it specifies it wants it in a certain form. Cat! Okay, so that is the end. Like I said, this is a much faster video, because most of it you should already know from GCSE, so it's fairly simple. I hope you enjoyed it. If you can you like, subscribe, comment, try and draw attention to this video, because I'm fairly new to it, so I want as many people to see the videos as possible so I can grow as a channel. Thank you so much, and I hope this was useful. Bye bye.